Okay, we're going to take some 5-4 notes today. Get started on section 5-4. So you're going to need your reference sheet again. And now we're going to use a different set of formulas that we've been using. So the first one says find the cosine of 15. Now, we already know how to find the cosine of 15 by rewriting 15 as something like 45 minus 30, or 60 minus 45, or something like that. Today, we're finding the cosine of 15 using what are known as the half angle identities. So if you look on your reference sheet, you will see some formulas that say sine theta over 2, or I don't know what letter you have, I'm not sure what sheet you have, but theta over 2, x over 2, or whatever, but half of an angle. So we're looking for the cosine one. This is a cosine problem. And we're finding the cosine of 30 over 2. So that's how we're going to think of 15. Instead of thinking of 15 as 45 minus 30 or one of those other things, we're thinking of it as half of 30. Half angle, half of 30. So the identity for the cosine of half an angle is plus or minus 1 plus the cosine of theta over 2. Now for us, theta is 30. This is the cosine of theta over 2. So I'm going to put a 30 right here. And my formula says that I'm going to do 1 plus the cosine of 30. Whatever that is, I'm going to divide it by 2 and then take the square root of it. Okay, so let's figure out the cosine of 30. You may have it memorized, but if you don't, here's our little triangle. You can always get your values from the triangles. So the cosine of 30 is root 3 over 2. This may be the first time, I really don't know, that you have seen a radical under a radical. It's perfectly okay. It's ugly, it's awkward to work with, but it's perfectly okay. Underneath that radical is a complex fraction. See, a big fraction with little fractions inside. So I'm going to multiply everything by 2. And that's going to cancel this out right here. That's going to go away. So now I'm going to have plus or minus 2 plus root 3 over 4. There's not a whole lot we can do with that. Numerator, in fact, there is nothing we can do with that. So our top is just going to be the square root of 2 plus the square root of 3. But the bottom is the square root of 4, which is 2. And now we're almost done. Now we have to choose whether we want the plus or the minus. These half angle formulas have a plus or minus option. And every time you do one, you have to, ultimately you have to pick. Do I want a positive or do I want a negative? Well, this one's easy. We're going to go back to the original problem, which is cosine 15. This is the problem that you are doing, you guys. Is the cosine of 15 going to be a positive number or a negative number? Well, 15 is in quadrant 1, isn't it? So the cosine of anything in quadrant 1 is going to be positive. So we're going to take the positive square root. If we had an angle that was in quadrant 2, then we would take the negative because cosine is negative in quadrant 2. Cosine is x. In quadrant 1, it really doesn't matter. Everything's positive. But as you move around different quadrants, remember cosine is x, sine is y. And there is your answer. Whew, yucky. Let's look at the next one. Tangent 67.5. Okay, so we're going to write 67.5 as half of something. Well, that's pretty easy. 67.5 is half of 135. So we're gonna do 135 over 2. The tangent of 67.5, we're gonna rewrite that as 135 over 2. Okay, so the angle of my problem is 135. I'm gonna go ahead and draw 135. It has a reference angle of 45. So this is 1, this is 1, this is root 2, but this one is negative. So the problem was 67.5. I have to use a half angle identity, so I'm thinking of 67.5 as half of 135. So now I'm going to do my formula. And I guess I'll just pick, really doesn't matter, there's 3 versions of this. So I'll do 1 minus cosine 135 over 1 plus cosine 135. So again, you need to be able to look at your formula and decide, or your formula sheet, I should say, and decide which one you're going to use. All right, so here I am, right here. Okay, and it's plus or minus. So now I'm going to go over here to my picture, and I'm going to put in the cosine of 135. Well, the cosine of 135 is negative 1 over root 2, or negative root 2 over 2. So I'm going to put that number right here. Now, it's negative, so this is actually going to become plus root 2 over 2. And then 1 minus root 2 over 2 on the bottom, because it's 1 plus, but that's a negative number, so it becomes a minus. All right, that's a mess, and it's going to stay a mess, but we're going to at least times it by 2 to get rid of the complex fraction. So these are going to cancel when I do that. So I have plus or minus the square root of 2 plus root 2 over 2 minus root 2. Oops, and you can leave it like that, okay? We're not going to mess around trying to rationalize that, but we do have to choose whether we want the plus or the minus. So here we go. Do I want the plus or the minus? Well, let's go back and look at our problem. Our problem is we want the tangent of 67.5. Think about this for a second. If you type that in on your calculator, don't, but if you did, would it come out positive or negative? Shoot, it's going to come out positive because 67 is in quadrant 1. So once again, we have a positive. If this had been 167, then it would be in quadrant 2, and then it would be negative. But it's in quadrant 1, so it's positive. All right, number 2. These are just like the ones we did before, where you have to look at your formula sheet and figure out which formula you have. So it's a square root of 1 minus cosine 47 over 2. I did a really bad job of writing this problem. Make sure that radical is supposed to go all the way down. It's supposed to go all the way down like this. Okay, so look on your sheet. That is a formula for the sine of x over 2. This is the half angle formula. Would you agree with me? This is the half angle formula. 1 minus cosine over 2. Well, what is my x? My x is whatever makes 47. So what makes 47, what makes, no, my x is 47. So that is 47. Because my formula says, let me write my formula out. Sine x over 2 equals 1 minus cosine x over 2. So that x are the same thing. So this is the formula for the sine of 47 over 2, which is the sine of 23.5. So that is the answer to the question. Your formula, when you saw 1 minus cosine over 2, you should have looked for this formula, which happens to be the sine of x over 2. Those x's are the same. So since that's a 47, this is a 47, and 47 divided by 2 is 23. Sine squared minus cosine squared. Now this one is a little bit tricky because you can look all over your sheet and you aren't going to see that. You are going to see something close to it. What you're going to see is cosine squared minus sine squared. So you see the backwards of this on your sheet. So what I'm going to do is, I think we did this the other day, I'm going to pull a negative out, and this is going to be cosine squared minus sine squared. If I pull out the negative. Now, this right here is a formula for what we call the double angle cosine. It's a formula for the cosine of twice the angle. Look on your sheet. Cosine 2x is cosine squared minus sine squared. Okay? So this is a formula for the cosine of twice the angle. What angle? 87. So this is a formula for the cosine of 174. But don't forget, to make it work, we had to pull a negative out. So the answer is actually negative cosine 174. If your formula is backwards and it's a plus, there's no problem. But if it's backwards and it's a minus, you have to pull that negative out in order to turn it around so that it's in the right order. All right, 2 tan over 1 minus tan squared. That is a formula. Look for it. Look for it on your sheet. That is a formula for the tangent of twice the angle. So again, if you look on your sheet, I don't know what the letter is. I'll use X. But you have this. This is on your sheet. And what it says is tan 2x equals 2 tan x over 1 minus tan squared. That is on your paper. This problem has this exact thing, but instead of x, it has 73, which means this is 73. So this is a formula for the tangent of 2 times 73, or the tangent of 146.
Of course.
Okay, we're gonna do one more section here. We're doing number 3. It's got a few problems on it. We'll do number 3, and then I'll be done by now. All right, so here we go. Number 3 is a solve, and it's in degrees. Now, you might notice, it looks very much like some of the other problems that we've done, but you might notice there's a difference. This one has a 2x. When your problem has a 2x in it, you want to look on your sheet and find the formula for, in this case, the sine of 2x. You want to get rid of that 2x. You want to substitute it out with its formula. So the sine of 2x is 2 sine x cosine x. That is on your sheet. So I simply took the sine of 2x and replaced it with its formula, 2 sine cosine. Now we had an equation that looked just like this a couple days ago. Exactly like this. We decided we were not going to divide by sign because you can't. Sine can be 0, and therefore we don't divide by it. So instead, you remember what we did? We subtracted it over. Got a 0, in other words, move this over. And then we factored it out. Now that is an important thing to remember, kids. You do not divide by one of your trig functions. Instead, subtract it over and then factor it out if it's possible. Okay? Once you get it factored out, then you set these equal to 0. So sine equals 0. Or, I'm going to set this equal to 0. Cosine equals 1/2. And then it's just like the ones we've been practicing. Where does sine equal 0? Remember, if it's a 0, we're somewhere on our circle. And if it's sine, it's y. And it looks like y is 0 right here and right here. We're in degrees, so we'll say 0 and 180. So the answer to the first part is 0 and 180. Okay? Now, where is the cosine 1/2? Well, cosine is x. X is positive. This is a positive 1/2. X is positive in quadrant 1 and quadrant 4. The cosine is 1/2, which makes this a √3, which makes this a 60. So the answers to that part of the problem are 60. That's this guy right here. But this is also 60, and I gotta go all the way around. So how big will that one be? 360 minus 60, or 300. So there are the answers to that problem. All right, that wasn't too bad. That was kind of easy. All right, let's look at the next one. Same sort of thing. So you know, because we just did it, that you've got to change that cosine 2x into something. Now you'll notice on your sheet that there are different versions of cosine 2x. Cosine 2x can either be this right here, can either be cosine squared minus sine squared. We used that one actually a minute ago in a problem. Or it can be 1 minus 2 sine squared. Or it can be 2 cosine squared minus 1. Okay, all these are on your sheet. And if they're not, they will be. You can add them on. These are all versions of cosine 2x. So any one of them will work. There isn't a wrong, one to pick. But one of them is going to make our life the easiest it can be. Notice that besides that, the problem also has a regular cosine. So I'm going to choose this option because then my whole problem will be regular cosines. If I picked one of these, then I'm going to have sines and cosines in my problem, and that just makes it more complicated. So I'm going to pick this one right here. So I'm going to take that, and I'm going to substitute it in right there. So I'm going to have 2 cosine squared minus 1 equal to cosine. All right, now what do I need to do? Well, it's a quadratic equation, guys. Get that set equal to 0. So I'm going to move that cosine over. And when I move it over, I'm going to move it over in what I would call the right spot. I'm going to put it right here in the middle. I subtracted this cosine over. Hopefully you're looking at that and thinking, oh my goodness, that factors. Because it does. So how is that going to factor? 2 cosine and cosine. It's going to have to be 1 and 1, so I just need to figure out my signs. I need this one to be minus and this one to be plus, so that when I FOIL it out, my middle term is negative. -2, +1. So what happens? It says cosine is -1/2, or cosine is 1. All right, where's the cosine negative? Where's cosine -1/2? Well, cosine is negative where x is negative, cosine's x, so that's over here. Cosine is 1/2, so that's a √3. So don't I have a 60 again? But be careful, gang. Please be careful. 60 cannot be your answer because you're in quadrant 2. So your answer is actually 120, 180 minus 60. And then this one will be 180 plus 60, or 240. So there are the answers to this guy. That's where the cosine is -1/2. Okay, now, where's the cosine 1? Well, 1's a special number. Let's look around our circle. Shouldn't have erased this. Cosine, remember, is x. Where is x? 1. Well, x is 1 right here, so that's 0. And that's the only place x is 0, or I mean x is 1. That's the only place x is 1. Don't come over here, because over here it's -1. So this is it. For that right there, this is your only answer. Good work. All right, one more. You guys are doing great. We're gonna do one more. All right, this one is chock full of cosines. So using the last problem as kind of a jump start here, this is the one of the identities that has multiple options. They're all on the formula sheet. If they're not, you're gonna write them on there. You wanna pick the one that seems like it's gonna make your life the easiest. All of them will eventually give you the right answer. You just wanna pick the one that's gonna be the easiest. So, I had them written here, I just erased them. Your choices are cosine squared minus sine squared, 1 minus 2 sine squared, and 2 cosine squared minus 1. So it seems to me, again, because all these are cosines, that we're going to change this into this. That just makes sense. So, cosine squared plus cosine equals 2 cosine squared minus 1. So let's shift everything over. Oh my gosh, I think, am I gonna get the same thing? Let's shift everything over. So we're gonna set it equal to 0. So I'll have just 1 cosine squared. Oh no, that's different. I'll have just 1 cosine squared minus cosine minus 1. Shift everything over to here. So my equation's set equal to 0. I could take everything over there, but I just have this issue with my leading coefficient being negative, so I like to just move it all over here. Uh-oh, here's the bad news. This is pretty bad news. That does not factor. That is a quadratic formula, or quadratic equation, just like x squared minus x minus 1. That doesn't factor. So my A is 1, my B is -1, and my C is -1. So I'm going to need the quadratic formula. Oh yeah, here we go. Cosine x equals, so we're not solving for x. Here I would be solving for x. Here I'm solving for cosine x. That's my variable. So cosine x equals plus or minus the square root of b squared minus 4ac all over 2a. Regular quadratic formula, using that a, b, and c straight out of my problem. So what have I got? Underneath there is going to be the square root of 5. I think. So the cosine of x, just like the one I'm erasing right here, see how I have two cosine values from my factors? I'm going to have two cosine values from my quadratic formula. I'm going to have cosine x equal to 1 plus root 5 over 2. And I'm going to have cosine x equal to 1 minus root 5 over 2. Now, there's no way that I can do this without a calculator. 1 plus root 5 over 2 is a positive number. That number will be positive. So I'm going to use my calculator and I'm going to find angles where cosine is positive. Quadrant 1 and 4. I'm going to use my calculator in just a minute. 1 minus root 5 over 2 is negative. So I'm going to use my calculator and find angles here. Now, the other problems that we've done, we have known, like this has been root 3 and 2 or whatever, so we've known that reference angle. We've known this reference angle. I need to use my calculator to find the reference angle. Okay? So here's what I'm going to do. I'm going to type in second cosine 1 plus root 5 over 2. Okay? So second cosine 1 plus the square root of 5. Oh, wait a second. You know what? You're going to need a lot of parentheses here. It might be easier, actually, now that I think about it. Let's go ahead and type this number into our calculator. So just type 1 plus the square root of 5, close the parentheses, or hit equals, divided by 2. So 1 plus the square root of 5 equals, divided by 2, and I got 1.618. Right, try that again. 1 plus the square root of 5 equals, divided by 2. Okay, you should have gotten 1.618. All right, now, second cosine, second answer. So in other words, whoa, second cosine this number. Now, you're going to get an error because that number is bigger than 1, and we just discussed that cosines and sines cannot be bigger than 1. Remember we had a problem where sine x equaled 3? Not possible. You cannot draw a picture where the adjacent side is 1.6 and the hypotenuse is 1. That doesn't make any sense. So there's no solutions to that one. Okay? Now, let's do the other one. Same thing. So let's type in 1 minus the square root of 5 equals divided by 2. So 1 minus the square root of 5 equals divided by 2, and I got negative 0.618. Cosine's a little tricky. Second cosine's a little bit tricky. If you type in second cosine, that number, so if you second cosine that answer, you get this angle right here. You actually get your answer, which is 128.17. You do not get the reference angle. You actually get that angle right there, which is fine. That's an angle. That's an answer. But then you got to figure out the other one. And does it make sense to you that if that's 128.17, this is also 128.17? Only I'll mark it negative because I'm going the other way. So we need a way of coming up with this red angle right here. Can you think of a way to do that? Sure. what if you took 360 minus that 128? Wouldn't that give you your red angle? So your answers to the question are 128.17 and 231.83. Your answers have to be between 0 and 360. So you can't say negative 128.17. That is an answer, but you can't use it because it's negative. So we'll just find a coterminal angle, we'll add 360 to it, and get 231.83. Now, real quick before we go, I want to show you, this can be a little confusing. It's a phenomenon with the cosine. I'm going to go back to where I was a little bit ago. And I had typed this in and got negative 0.618. And I actually second cosigned that number, which is absolutely fine. And then, but that caused this to happen. So if you're going to do that, you got to deal with that, which is fine. We did. It's okay. If you do second cosine positive 0.618, you will get the reference angle. So the reference angle is 51.83. Then you can find your actual answers. I got that by second cosigning the positive. I just left the negative off because whenever you do just the positive, you're going to get your reference angle. So I second cosigned 0.618, and that gave me a reference angle of 51.83. So this right here is one of my answers, and it will be 180 minus 51.83, which is that number. And then the other one, my other answer, will be 180 plus 51.83, which is that number. So you can get your answers either way. It makes no difference. It's just whatever way you are comfortable with. Just know that when you type in the negative, you're not going to get the reference angle. And as long as you can figure that out, like we did up here, it's all good. It's all good. All right, that's that. Hope you're having a great day.